Okay, so before we tackle the pendulum, we want to just kind of review what's going on in here, and it'll be easier to make that transition. So let's look inside of our mover orientation and kind of describe what is going on. This right here, this updates the orientation plane, so it's similar to the position plus equals velocity, so it's the same as position. It's similar to position equals position plus velocity, and then what we have above it is similar to velocity, so it updates the orientation plane of velocity, and it's similar to velocity plus equals acceleration. So with our pendulum example, we need to calculate acceleration. And so we need to do that. And then also we're going to be dealing with gravity. So we want gravity, the magnitude of gravity, we're just going to have 1. And then the gravity vector is going to be equal to, as you might assume, 0, 0, negative 1. Okay, so let's address this. Because we're not going to be passing in an acceleration, we can delete this out, and then our OV acceleration is going to be equal to 0, 0, 1. And this is because, like I was discussing with our orientation vector, we want it in terms of the z-axis. So that should be clear. And then the self OP, if we do it the world, we're going to have the ball of the pendulum sticking straight up off of the z-axis, so we want to have it off to the side. We're going to go oriented plane, and it's going to be 1, 0, 0, 1. And I'll show you what this looks like when we move into our example in the next video. Okay, so we have this, what I can think about. I think I did change the name of this between the last video and this video, the updates. I think it was rotate, but I changed it to updates in between the videos, so you need to change that. We don't need acceleration anymore because we're not passing in acceleration. And so this basically gives us the setup that we'll be using to tackle the pendulum example.